Hello students, this is week number 5, lecture 2, and the topic we are studying graphs of exponential function. In the last lecture we studied three important things. What is an exponential function? Then what are the properties of exponential function? And then the third one, the questions based on exponential functions, that is properties, particularly properties of exponential function. Now today we are going to study the very important topic, graphs. How do we draw the graphs of function? In previous chapter we learned how to draw the graphs. Clear? In case of linear function it was very easy. We were finding x-intercept, y-intercept, and because it is a straight line, so we were matching these 2 points. That's all. In quadratic function, the graph, we need 3 important points. First we need the vertex, then we need the x-intercept and the y-intercept. If it is a positive parabola, so we are matching all the points and opening it up. If it is a negative, means downward parabola, we are making it down by matching all these 3 points. Clear? Here the story is different. Graphs of exponential function. In the graphs of exponential function, there are 2 important things. First important thing is you need to draw a table. Let us take some example. Okay, example is draw the graph of fx equals to, or sometimes we write it y also, 2 power x. This is the simplest graph. Y is equal to 2 power x. So how to draw this graph? My dear friends, please make a table. This is very important. Table between the values of x. Okay, this is x and this is y. Clear? And it is up to you. You are taking what values or not values. I will start with zero, then 0.5, then 1, and then 1.5 and 2. I generally choose these values of x in case of exponential function. Only in exponential function, please remember, we'll take the central value 0 and 4 values this side and 4 values this side. And I always choose 0.5, 1, 1.5 and 2. Here negative 0.5, negative 0.1, negative 1, negative 1.5 and negative 2. These are the values. Now try to use calculator, open calculator parallelly, clear, and write the values, clear. So here it is 2 power 0. Okay, I will make another column because this is the first question, so you should understand how we are calculating. It is 2 power 0, 2 power 1, 2 power 1.5, 2 power 2, 2 power 0.5. This is 2 power 0, 2 power minus 0.5, 2 power minus 1, 2 power minus 1.5, 2 power minus 2. Clear? To some values we can write directly. Any number with 0 exponent is 1. 2 power 1 is 2. 2 power 2 is 4. Clear? 2 power minus 1 is, I know it is 0.5, and 2 power minus 2 is, it is 0.25, like this one. Rest values we need to evaluate with the help of calculator. 2 power, it is 2 power how much? 1.5. So it is 2.82. So here it is, this value is 2.8. Clear? Then we'll take 2 power 0.5, 1.4. It is 1.4. 4. Then 2 power minus 0.5. 2 power minus 0.5. No, something we call it wrong. Okay, 2 power 0.5 negative it. 0.7. So this value is 0.7 and 2 power is 2 power 1.5 with negative. It is 0.35. So let us take 0.3. So this is the first step, making the table. Clear? After making the table, we will draw the x-axis and y-axis. This is x, this is y. Clear? 1, let us take 0.5, 1, 1.5 and 2. Minus 0.5, minus 1, minus 1.5 and minus 2. Minus 1.5, minus 1, minus 0.5. This is 0, 0.5, 1, 1.5 and 2. And let us take this is 1, this is 2, this is 3, this is 4. Okay. So 2 power 0, it is at x is equal to 0, it is 1. X is equal to 0.5, it is 1.4 here. X is equal to 1, it is 2. X is equal to 1.5, it is 2.8. And x is equal to 2, it is 4. Like this one. X is equal to minus 0.5. Minus 0.5 is 0.7. Almost here. Minus 1, it is 0.5. Almost here. Minus 1.5, it is more or less 0.3. And this, it is 0.2. Now join these points. If we join these points, the graph will be like this one. This is. So this is the graph of fx equals to 2 power x. What you can do is, you can mark these points. This is 2 comma, how much? 4. This is how much? 1.5 comma 2.8. This is 1 comma 2. This is 0.5 comma 1.4. This is 0 comma 1. So you can mark these values. It is minus 0.5 and 0.7. It is minus 1 and 0.5. It is minus 2.25. Like this one. You can mark these values on the graph. So this is what are the 4 important things. You will see it is continuous. Like this one. It is a continuous graph. It is increasing, going up, increasing, and domain is R and the range is R positive only. So these are the 4 important things in this graph. So this is graph of exponential function 2 power x. Clear? If I write the graph of 2 power minus x, now you see what is the change in graph of 2 power minus x. 2 power minus x. Clear? We'll make the table. It is x, it is y. So it is minus 2, minus 1.5, minus 1, minus 0.5, 0, 0.5, 1, okay, sorry, 1, 1.5 and 2. Clear? Because here the graph is 2 power minus x. So it is 2 power 0, 2 power minus 0.5, 2 power minus 1, 2 power minus 1.5, 2 power minus 2. because the function is minus x. So, and if x is negative, 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 positive. So 2 power 0.5, 2 power 1, 2 power 1.5 and 2 power 2, because here is negative and this negative will change into positive. Clear? If we see these values, if you compare this table from the previous table, you will find all values are here. Only the position is changed. The negative values comes, look, in the previous table, if you will see, here the positive values, this side is positive values and this side is negative values. But in this graph, the same values, but this side is negative, this side is positive. Only side change. So if we see 2 power 0 is 1, 2 power minus 0.5, it is 0.7. Then 2 power minus 1, it is 0.5, it is 0.3, it is 0.25. 2 power 0.5 is how much? 1.4. How much it is? 2. It is 2.8 and it is 4. So the values are same to same, only their position changed. Clear? Here, if you see the graph, clear? Here 0.25, 0.3, 0.5, 0.7, 1 and 4 means here the values are increasing. Values are increasing. But because the graph is 2 power minus x, you will see here the values are decreasing because it starts with 4 and reaching up to 0.25. So the values are decreasing here. So if we draw the graph here and we will make like this one, because of space constraints, I'm not able to make it clearly, but no problem. It is 0.5, it is 1, it is 1.5, it is 2. It is minus 0.5, minus 1, minus 1.5, minus 2. And let's say 1, 2, 3, 4. So here it is 2, minus 2. And minus 2, the answer is 4. So it is here. Then minus 1.5, the value is 2.8 here. Then minus 1, the value is 2 here. Then minus 0.5, the value is 1.4 here. And the value is 0, it is here. Clear? Here, here, here and here. So you will see the graph of the function is decreasing, 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 decreasing like this one. Clear? So this is the graph of 2 power minus x. Or you can write it 1 upon 2 power x. Both are same. So as earlier I explained you in the previous chapter, here it is 2 power x. 2 power x means a is equal to 2, greater than 1. So the graph is increasing. But if you see here is a is equal to how much? A is equal to 1 upon 2. 1 upon 2 means less than 1. So the graph is decreasing. Clear? So you can notice all these things from the graph of increasing function and decreasing function. Another point also, if you see, it is just a reflection, mirror reflection. You just put a mirror here. This is the y-axis. You can consider y-axis as a mirror. And if this is a x-axis, this is x-axis, this is y-axis. What was the graph of 2 power x? The graph of 2 power x was like this. And what was the graph of 2 power minus x? It is like this. This is 2 power x. This is 2 power minus x. Clear? So this is just a mirror reflection. Whatever it is coming here, it is up, it is up, it is down, it is down. So it is mirror reflection. Now you can draw the graph of 3 power x, 4 power x, 5 power x, 10 power x. You can 3 power minus x, 4 power minus x, 5 power minus x, 10 power minus x. You can draw any graph. Clear? What will happen? Here 2 means this one and 3 graph will be like this one, little more up. 5 power x will be little more up like this one. 10 power x will be little more up because 10 power values will be higher. So it is 2 power x, like 3 power x, 5 power x, 10 power x. So only this is the change. Graph formation will be like this, same to same graph formation, but values will be more higher. Here it will be more up, here it will be more down. If we are choosing a more greater, if we compare these values, for 10, the positive side it will be higher, negative side it will be lower. 3 power x, it will be less higher, less lower, like this one. This is about the graph of 2 power x and 3 power minus x, like this one. Another thing I want to explain you. Okay, let us take a graph here. We will take one example. Example y, graph of y is equal to, let us say, 5 power x minus 2. Let us take this one. Clear? And here we are taking greater than. The values we are choosing is greater than. We are not taking equal. We are taking greater than. Okay. So the process is same to same. There is no change in the process. Clear? How we are going to do? Okay. Let us draw the table here. This. Oh, sorry. What is this coming? Okay. X, y. So we will start with minus 2, minus 1.5, minus 1, minus 0.5, 0, 0.5, 1, 1.5 and 2. This is clear. So if we put these values, what will be? It will be 5 power 2 minus 2. 5 power 1.5 minus 2. 5 power 1 minus 2. 5 power 0.5 minus 1 minus 2. 5 power 0 minus 2. 5 power minus 0.5 minus 2. 5 power minus 1 minus 2. 5 power minus 1.5 minus 2. 5 power minus 2 minus 1. This is minus 2, sorry. This is. Now you need to find the values of these. So we'll use calculator. Some values we can find directly, but some cannot. So if 5 power 0 is equal to 1, so the answer will be minus 1. And 5 power 2 is 25 minus 2 is 23. 5 power 1 is 5, 5 minus 2 is 3. Clear? Let us say. And this also we can find is 5 power 1 upon 5 is 0.2. So this is minus 1.8, like this one. Okay, let us take it. So it is 5 power 1.5. 1.5. This is minus 2. So how much? 9.1. This value is 9.1. 5 power 0.5. 5 power 0.5. This much minus 2. It is 0.23. So we will put it 0.2. Okay. Now we will take 5 power 0.5 but negative. Clear? Is equal to minus 2. How much? Minus 1.5. Minus 1.5. 5 power minus 1.5. 5 power 1.5 with negative equals to and minus 2. It is 1.9 minus 1.9. Clear? And the last value is 5 power, okay, sorry, 5 power 2 but negative. It is minus 2. So it is 1.96. You can 1.96 you can take. So if you will see here, it is how much? Now one thing I want to tell you here, this function is different. We are subtracting -2. Clear? So the domain will be, if somebody asks you what is the domain is R, no doubt, because the values exist on positive side as well as on negative side. But range is little different here. What is the range? In previous question was R positive, 0 to infinite, but here the range starts with -2. So range is -2 to infinite. Please remember this question. Range starts with -2 to infinite. And one more thing, it will not equal to 2. It will be greater than 2. Greater than -2. Clear? Okay, let us see how I am telling all these things. This is the graph. Actually, the space problem is here, and also I cannot make the straight lines on this because it is, my pen is very slippery. So it is 1, 5, 10, 15, like 20, -5. Okay, let us say here I am taking -1, -2, -3, -4, like this one. But here I am taking 5, 10, 15 or 20, like this one. Clear? So you can say this, I am making one line here at 2. At 2 I will make this one line. It will be very helpful for you. And if you see here, the value at 0 is -1. Here 0 is -1, and value at 0.5 it is 0.2, 0.5 it is 0.2. Here value at 1 it is 3, almost here. Value at 1.5 it is 9, almost here. And value at 2 it is 23 here. Clear? And if you see the value at -1.5 it is -1. No, -1.5, almost here. -1 value is 1.8, negative, it is here. -1.5 it is 1 point, almost touching, and -2 it is more touching. And if we join these curves, clear? This is the graph of 5 power y is equal to 5 power x -2. This is equal. Clear? And you will see the graph is starting from -2. That's why I told you, because -2, it is graph starting with -2 to infinite. Clear? Now because it is an inequality, so put x is equal to 0 and y is equal to 0. So if we put, so 0 is greater than 5 power 0 -2. 0 is greater than 5 power 2 is 1 -2, and 0 is greater than -1. If this is true, so this will include in the region. This is this point. If this is true, this include in the region. If this is not true, then this side will be the region, opposite side. Clear? 0 is greater than -1. And my dear friends, this is true. 0 is always greater than any negative number. So it will be this region. This region will be the answer. Please look here. This is the answer. So here means in this case, equal case, only line is the answer. This line is the answer. Clear? But when it is inequality, then the region is the answer. This is the answer. This region. Okay. So in inequalities, what you need to do is you need to put 0, 0. If it is true, so 0 will include in the answer. So 0, look, 0 side, origin side. And if it is false, then this side is the answer, other than 0. Okay. So this is about the graphs of exponential function. Now I want to tell you one special type of function that is named as exponential function. And that is fx equals to y equals to e power x. This is a special type of function that is very useful in graphs because we will change exponential into logarithmic. Then this e is very useful. What is the value of e? It is 2.718. So the function is same to same. Only the value of a here is e means 2.718. This is the change only. So you need to remember this. This is very important and it arises naturally in many areas. Clear? And the graph and properties are just same to same. So you can draw the graph. If say you want to draw the graph like let's say e power 2x, you want to draw the graph of e power 2x. So if you will take x is equal to 2, you want to find the value of x is equal to 2, e की power 2 times 2, so e power 4. So in calculator what we need to do is in place of 2 or 3 or whatever, we need to put e power x. Where is e power x? E power x will be written here. Some e power x will be there. Yes, this is e power x. So e power, this is there. You want to put 4 and e power x. So this is 54.59. What is the value of it is? It is 54.59. So it is same to same. If it is e power 3 times e power 4 we are writing. So because base are same. So e power it will be 3 plus 4 e power 7. All properties are same to same. All values are same to same except one change. We will take a equals to e and the value of this is 2.718. Clear? So that's all about this topic e power x, and this also end your syllabus for midterm, first midterm. So we will cover up to page 30 from page 6. This is page 6 to page 30 is your midterm. Only one midterm is there. So midterm syllabus. So please practice these questions as previous chapter and this chapter. And if you face any difficulty, please write to me in chat box. Clear? Till then, thank you very much. Take care. Stay safe.